Okay, so let's try to do sensitivity analysis as we would with a one-way data table in Excel. So, if we wanted to compute profit for different values of order quantity in Excel, we'd just do literally a one-way data table. In Python, what we could do is set order quantity equal to a vector and then recompute profit. Right? Our model should then just spit out a vector of profit values, since Python is a vectorized language. So let's start by creating a vector of order quantities. I'm going to use the NumPy arrange function, which is returns evenly spaced values within a given interval. Perfect. Okay, so I'm going to start at 50. I'm going to stop at 301, and I'll do it in steps up 325. And so we see that there's my order quantity. So a couple questions. Why did we set the stop equal to 301? And what's the data type of this thing? So, you should try that quickly yourself. And if I go out to the NumPy page, right, the stop value, stop is the end of the interval. The interval does not include this value. So if we want to include 300, then we need to go up just slightly above 300. And you might quickly look and say, oh, this thing's a list, but it's not. Right? These things aren't comma-separated values. All right, so let's do a type of that. And you might have already guessed, well, if we used a NumPy function to do this, it's likely this guy's going to be a NumPy array. And it is. Okay, so now I'm going to rewrite all of our formulas, and notice I have, up above here we used min and max, but we can't do that anymore. If we're going to pass order quantity in as a vector, we actually have to use the NumPy versions of minimum and maximum. And the reason being is that we need to make sure that, for example, order quantity is a vector and demands a single number. So what has to happen is something that's called broadcasting. So since, let's say there's 10 order quantities and one demand, the demand will get broadcast to a vector of 10. You can think of it that way. And then the minimum will be of each of them. So this whole quantity will get a whole vector of these things that we multiply by a single selling price, which gives us a vector of sales revenue. So sales revenue should be a vector, refund revenue a vector, profit a vector. Okay, so that's the whole idea. And if you remember back in R, we ran into the same idea. In R, we called it recycling. In here, in Python, we call it broadcasting. So there's profit. And if you want to, it's a good idea, just prove it to yourself. Take a look at, for example, sales revenue. All right, that's also a vector. Okay. And just real quick, you should ask yourself, why did it show array here, but it didn't show it here? It's just because I used print here and I auto printed it here. And so also, just to show you, I'll do the minimum on order quantity and demand. Remember, this is a vector that demands a single number, right? And so now you can see I did get the minimum of the order quantities until it goes up over the demand of 193, and then from then on, 193 is the smallest. Okay. And if you try the original min function, it'll say the truth value of an array with more than one element is ambiguous. So it doesn't know what to do with that when it tries to compare. Basically, the problem is when it tries to compare vector to a single value. And we can go ahead and plot this guy in matplotlib. All right, and we see profit. Nice, as a function of order quantity with everything else held fixed. The profit, at least it's unimodal. It actually seems to obtain a maximum around 200. So now what about a two-way data table? Couldn't we do the same thing? Just set the, let's say we wanted to use demand as the other thing that we want to let it vary over a range. Couldn't we just set it to a vector and do the same thing as above? think about that. We'll kind of answer it a little below, but no, we can't. Okay, so let's think about why that's not a good idea. So instead, what we'll do is we will create a function called bookstore profit. And what we're going to do to make sure that we get all of the individual scenario values, which will become more concrete in a second, is we're going to call this thing from inside a list comprehension with a couple of loops. And we'll be looping over the input variables that are vectors. And in fact, one nice thing about this is that we can actually extend this, whereas Excel can only do up to two-way data tables. We can do n-way. We can do as many as we want, with as many outputs as we want, which is really nice. So I'm gonna define this bookstore profit, and notice again we're using the NumPy versions of the functions inside. So now I'm going to do a list comprehension to show how we can do that. So before we jump into that, let's do a first simpler example. Let's compute the difference between demand and order quantity. So notice what I'm doing here first. I'm just creating a range of demands and a range of order quantities using the np arrange function. And I'll just print those things out just so we see what they are, right? And they don't have to be the same size. So I'm letting demand vary, in steps of 10 from 50 to 100, and I'm letting order quantity go from 50 to 100 in steps of 25. So, I mean, we're going to use bigger ranges in the real problem, but just to give you an idea. So now I'm going to use a list comprehension just to list all the combinations. I want all the pairs. I want 50 with all of these, and then 60 with all of these, and 70, then 80. That's what we need to do, and we'll store these combos in each of them in a tuple. And these things are a scenario, right? Let's think of them as a scenario is one specific demand value, one specific order quantity value. So I'm going to do a list comprehension. I'm going to loop over for D in demand range, and I'll loop for O in order quantity range. And I'm just going to, the thing I'm going to create in the list is just a tuple of the values of D and O, right? So those are all of my scenarios. And, obviously we don't have to just to do that. We could do something different, and at this time, in fact, I'll compute a list of differences between the demand and order quantity. I'll do D minus O for those two lists. All right, and there they are. And so that's just the you can see, right? 50 minus 75 is minus 25. All right, so now we're ready to do a two-way data table with demand and order quantity. We'll hold the other inputs constant, and then we're going to use that bookstore profit function that we just defined. And what we'll do, we're going to write the list comprehension to give ourselves a list of tuples to tell us what the scenario is, the demand and the order quantity, and then also what the profit is. And again, think down the line of what you want to do with this thing. So for example, what I'd like to do is get this thing into a pandas data frame, right? You can picture that the pandas data frame is almost like the Excel data table output that we can use then to just look at the table or drive a graph or whatever, okay? So create my demand and order quantity range. So now those things are, the full ranges we want to look at, 50 to 300. All right, so here's the actual, this is literally making the Excel data table. So remember, we decided what we're gonna return is a list of tuples, the demand value, the order quantity value, the profit value, and to get the profit, I actually have to call the profit function. And then notice, right, unit cost, selling price, unit refund, those things aren't varying, so those are just single numbers. O, Q, and D, those are our looping variables, for the specific demand and order quantity scenario values. All right, so this will create a list of tuples, and then I'm going to convert that list of tuples to a data frame. It turns out that the data frame kind of constructor function is really flexible. It is happy to take all kinds of things, lists, dictionaries, and here we're doing it with tuples. So it'll say like, oh, that'll be column 1, that'll be the second column, that'll be the third column. And so since it won't have any names, I'm going to pass in column names like this. And then I'll show you the first 25 rows of this thing. So we'll do it, and there we go. So so there, each row is a scenario. We get our demand, order quantity, and our profit. This is just like a one-way data table with a two-way data table with one output in Excel, except that usually when Excel does it, right, it would have demand going down, it would have order quantity going across, and then we could fill this in with profit. And that's why you can only have one output cell. We can have as many as we want. We could have 10 outputs if we wanted to. And here I'll go ahead and I'll just do a quick scatter plot of these things, and then I'll map the color to profit, the color hue, and so we can see, right. So dark is highly negative, and the really light green is positive. So it makes sense, right? We make the most money up in the upper right. That's when demand is high and we ordered a lot. We lose the most when we order a whole bunch and demand is really low. Okay, great. It makes sense. Just for fun, I thought I'd do a 3D plot just because we can. Just to check it out. And again, we get the same thing, right? So when order quantity is high and demand is high, that's when we get the highest profit. And we get the worst profit down here when order quantity is high and demand is low. So we have just created, an n-way data table in Excel, or I'm sorry, in Python, using a non-object oriented approach. And now what we're going to do is we're going to rebuild that thing, but we're going to do it in an object oriented way. And we're going to see, both the challenges that brings, but also the positives that it brings. And then we'll kind of decide which of those two is best for going forward for adding a goal seek function and a simulate function.